Welcome to Fxai. Today we will build a tree destruction scene. Let's start the session. Here we can select the type of FX. We will go ahead and select RBD for the tree destruction, where a cannonball hits a tree. Before we jump to Houdini, we will plan out the workflows we will need on paper. We will use material fracture to fracture the tree. We will need to switch from soft to glue, so that the tree bends and breaks. We want the tree to sleep and not be active till cannonball hits. We will need some point velocity to throw the ball onto the tree. Now we have got these prompts. Now let us jump to Houdini.
So to start with, we need a tree geometry. This tree geometry we have created in Houdini using L system. If we dive inside, it is a simple tree geometry created. If we come out here, we need a collision object. So for that we have used a simple sphere. The concept is that the sphere will be hitting the tree and tree will be falling and breaking into pieces. So to do that, we have to open the Fxai. Let me explain you how Fxai works. We have to log into Fxai just once and then turn on the live link. Once the live link is on, all we need to do is copy the prompts from the ChatGPT. What this will do in background, Fxai will use these prompts and generate a Houdini example for us on the fly. We can study the example and use the notes we want in our network. We don't need to keep reopening the UI anymore. All the magic will happen in background, so let's just keep UI minimized and focus on the FX. The first example, what we need is the material fracture. Let's just Control V here. So here you can see, we now have this Fxai example of wood material fracture. Now let's play this. We can see a wood material fracture simulation. So if we dive inside this subnet, we can see we have a complete setup for a wood material fracture. In this we have two types of fracture direction for wood material fracture. The first one is for the planks, where you can see it is using the fracture direction as the auto bonding box, which is default one. We can use this for the objects that require horizontal fracture. Other material fracture node we have here is for the poles that has the vertical fracture. We can get this type of fracture using the fracture direction as vector. So for our tree we will need this vector direction material fracture as we need the vertical fracture. So let's just copy this node that we need from the example and let's just paste it here in our setup. So now we have this node, let's connect it in our network. So here you can see we get a wood material fracture for tree. Now if we just use the exploded view node, we'll be able to see the fracture. Let's connect it to visualize fractured pieces. Now we have fractured our tree geo. Let's delete this and go to our next step. We also got the constraints form the material fracture node. Now what we need to do is we need to switch the constraint from soft to glue so that we'll get that breaking effect for the tree. So for that what we'll do is we'll just select this prompt. Generate an example of how to switch from soft to glue. And we will copy this prompt. Control C. Now let's just paste it here. So here you can see we got this example of Fxai. Let's move it. And turn around to see the geometry. If we display it, we can see that we have this switching of constraint from soft to glue and then breaking of glue constraints. So this example file is created for us. Let's just dive inside it. Here we can see the complete setup. In this we have RBD constraint properties node. In this node we are setting the constraint as glue and assigning next constraint as soft. Inside solver what we are doing is if we select this and we see we are switching the constraints using the angle threshold from soft to glue. So let's just copy these two nodes. And just paste them here. Let's connect this in our setup properly. And let's play the simulation. As we play this we can see the constraints are converting from soft to glue. Here in simulation we can see the green-colored soft constraints converting to red-colored glue from the starting frame. If you zoom here, you can see this constraint converting. We don't need the constraint to directly convert from soft to glue from the first frame before any collision. We need constraints to convert once they are hit by the sphere. So that means our tree should remain in sleeping state. For that, what we'll do is we'll go to our third prompt. Here we are generating an example of how to put the RBD object in a sleep state. Let's just copy this. And let's paste it here. So here we get example of object in sleeping state. So this example will have the setup where the object will be in a sleeping state until it is hit by a collision. Let's go inside the subnet. If we play the simulation and select the RBD bullet solver in here, we can see here geometry is red, which means it is in sleeping state, and once it is hit by the collision object it goes into active state. So from this example what we will be taking is this RBD configure node. If we select this node and in the node properties if we scroll down, we can see the state values are set for the active and sleeping state. So let's just copy this, and we need to put this in our setup. Let's just place it here. And let's connect it in our network. And now if we go to Bullet Solver and if we play, we can see this simulation. Let's zoom into the tree. Let's hit play. Now we don't have the constraint converting from soft to glue at the starting frame. The tree geometry is in the sleeping state. It will get switched to next constraint only when there is a collision. Without any type of collision the tree remains inactive. And we therefore don't have any constraints switching before collision as we wanted. So for the collision, let's give this ball a velocity and use this in our main setup. So for that we have to use a point velocity node to drive the velocities. Using our fourth prompt, let's just generate the example for it. Copy the prompt from here. This will generate us an example of how to use the point velocity to drive the velocities in RBD. After copying the prompt, all we need to do is paste it here using Ctrl+V. Once we do that, you can see we have the example, where we are using the point velocity on the fractured object. If we play this example, you can see we have a simulation of a fractured geometry. We have a velocity on these fractured pieces of the geometry. If we dive inside this example, you can see here in point velocity a velocity is added in y direction of value 5. Also below the point velocity node. In assemble node we are just making it as a packed object, and in this RBD configure we are setting it to active, so we will be needing these 3 nodes. Let's copy them and bring in our setup. We will need these nodes for our collision geometry. Let's paste these 3 nodes here. We will connect this node above the null node of our collision geometry. Here in the point velocity node, what we had in the example was in y direction, but here we'll be needing the point velocity in z direction. So let's just change that. We can put y direction value to 0. Here let's put z direction value as 20. Once we do that, now it's time to merge the collision object in our setup with our tree geometry. Here we are using the collision geometry as an active collision object. We need to connect it to Bullet Solver in order for it to act as an active object, and we will get both tree and sphere in the output of the solver. After this we will now connect merge node to the first and third input to our Bullet Solver. Let's go to our Bullet Solver now. Let's reset our sim. Now we have set our scene with all the nodes we need. It's time we go to Bullet Solver and play the simulation. Here we go. Here we can see we have a tree destruction setup ready. This tree destruction setup we have created within minutes using the Fxai examples we have. In this way we can use different RBD Fxai examples to create the large RBD setups in no time. Thank you so much for watching.
Support us on Patreon to know the latest updates and get your early access.